Hi, and welcome to Mr. Garofalo's podcast. In today's episode, we're looking at example 3 from today's classwork on piecewise linear functions. In this example, we're given the graph of a piecewise linear function. It has an increasing piece, a piece that's constant, and a piece that's decreasing. And we had started to come up with the characteristics of each piece by listing the slope and y-intercept from A to B, B to C, and C to D. So what we need to do with this information now is create 3 rules for each piece of the graph, and we also need to determine the intervals over which those rules apply. And we're going to do that by writing the formal piecewise definition for the function. So we would begin this by writing f of x equals, and then we would open a large set of curly braces. And in these braces, we're going to write the 3 rules in order. So the slope of segment AB was 1.5, and its y-intercept was 6. So we would write 1.5x plus 6. BC had a slope of 0 and a y-intercept of 3. So it's just f of x equals 3. And then CD had a slope of negative 1/2 and a y-intercept of 4. So it would be negative 1/2 x plus 4. Now each of these rules applies for different values of x on this graph. So we will need to specify when the rules apply. So next to each rule, I'm going to write the word when. And to the right of that, we're going to define the values of x for which the rule applies. So let's start with AB. So I look on the graph. I see that point A has an x value that corresponds to negative 6, and point B has an x value that corresponds to negative 2. So that means this rule, 1.5x plus 6, only applies from negative 6 to positive 2. And since the plots are filled in, we can include both of those values. So we're going to write the following inequality to show that this rule only applies when x is less than or equal to negative 2 and greater than or equal to negative 6. Now we move to the next piece. We see that the segment from BC goes from negative 2 to positive 2. Now, we already included negative 2 in the interval for the first rule. And since this is a continuous function, in other words, since all points along this graph are included in the function, we have some leeway with how we want to work with this. We can include negative 2 in the first interval. We don't need to include it in our second interval. So when I write my inequality, I'm simply going to use x is greater than negative 2. I already included it here. I don't need to include it again. As long as I include it in one of them, since it's actually the point at which both of them meet, we'll cover ourselves. And then it goes to positive 2. Now I'm going to include positive 2, which means I won't include positive 2 when I write the next interval. So we look for from C to D now. And we can see that this rule, negative 1/2 x plus 4, only applies when x is from 2 to 6. And once again, we already included 2 in the second interval, so I'm not going to include 2. I will, however, have to include 6. So there you have it. We've just written a formal piecewise definition for this function. It looks complicated when you first take a look at it, but all it really means is what's the equation of this line and where is it being graphed? What's the equation of this piece and for what values of x are we seeing its graph? And then what is the equation of this line and for what values of x are we seeing its graph? Okay, and we come up with this statement down here. So hopefully this is helpful for you. I'll see you in class soon.